Oh. Yes. Oh. Hey. Thanks for joining. Hello. Oh. Hi, am I the only one? Eta, KG. How are you, my friend? Yes. Thanks for joining, guys. Thanks for joining. Hey, am I the only one who is at Russia? No specific time. We are going to end this live once we are done. Ne? Okay. Hey, am I the only one who is at Russia? Yeah, I feel like it's cold today. Yeah, it's cold, ne? It's cold today. Today, I want to announce that we are done with trigonometry up until we meet again for the revision. Ne? We are done with Euclidean geometry. Hey, what do you? Hey, now I'm getting more Russia, bro. Yeah. Going to do Euclidean geometry today. Euclidean geometry. Yeah. Hey. We are going to have the tough one. Euclidean geometry. Hey, I'm shaking. I'm shaking. Euclidean geometry. So, unfortunately, I won't. There will be a session for grade 10s, but unfortunately, I can't start the Euclidean geometry on at grade 10 level. I have no choice but to do cyclic geometry. And yeah, I'm not going to explain theorems in details. Ne? You have to catch the drift. Lana siyagijima. You have to catch the drift. Let me do this. Lana, we are running. Ne? We are running. We don't do like I don't like emphasizing one thing and over. Is my camera clear, guys? Is everything clear here? Is my camera clear? Everything is clear? Can we start? Yes. Thank you very much. Hey, I'm even shaky. Yo. I'm even shaky. How am I going to approach this? I don't like saying thank you. I don't like starting with theorem 1, theorem 2, theorem 3, up until theorem 9, because I feel like Euclidean geometry is going to be the longest. Yeah, we are still going to talk about these cycles, the longest. I'm going to start from theorem 1 up to theorem 9 and proceeding up to proportionality, similarity, yara. So I'm going to study it from the grade 11 to grade 12. But to save time, I'm not going to explain the whatever reason. So now I'm going to start by saying, let's focus on the theorems that includes the center. Or maybe let me do this. Yeah. He looks like my head. Ne? Let's start by labeling this guy here. Start by labeling. What do we call this? Actually, wait, before. What do we call this? What do we call this? This part of the cycle. What do we call this? We are about to label the cycle. What do we call this? What do we call this? When will the grade 10 session start? I think Saturday, guys. Saturday. Circumference, Circumference, Thank you very much. Thank you very much. This is a circumference. It's a circumference, right? What do we call the line from the center? Okay, I will announce it Friday, ne? I will announce Friday. But I believe what is gonna be around 8 to 10. 8 to 10. Thank you. The line from the center to the circumference is going to be called a radius, ne? It's gonna be called a radius. So this is going to be a circumference, ne? And this one is going to be what? A radius. So what if I have two radiuses? What do we call that? If we have two radiuses, what do we call that? No, two radiuses. I'm not saying the line that passes through. Listen to my question. I'm saying two radiuses. Thank you. It's a radii, right? It's a radii, right? If I'm drawing this like this, these are two radiuses. Radiuses more than one, it's a radii, right? And now, what do we call this piece of the circle? This piece of the circle. What do we call this piece of the circle? It's an arc, right? No, it's an arc. The piece, this one. The piece, this one, is going to be an arc. Ne? What do we call this area? No, okay. No, sorry. Not the area. This one, it doesn't matter. It's not, even though we don't know it, it's fine. It's going to be called an arc, ne? So now, what do we call the line? Oh, congrats. Congrats to you. Congrats. Yeah, congrats. But the important one is the grade 12 one, eh? We have to get 100% to the grade 12 one. So what do we call the line that from chord to chord? No, from circumference to circumference. What do we call that line? This line. What do we call it? It is a chord, right? This one is going to be a what? A chord. And what do we call this? What do we call that area? What do we call this area? It is a segment. Here is a segment. This one is going to be a segment. So we have two types of segment. What do we call this one? Who can tell us? What do we call this one? We have two types of segments. What do we call this one? What do we call this one? Yes, can someone confirm? Thank you. This one is a minor segment, right? This one is a minor segment. And this one, what do we call this one? This large one. What do we call what is the name of this large one? It's gonna be Why is it a minor segment? It's because of its minor. It is the small segment. It is a big segment. We have a, yes, this one is going to be the major segment, and this one is going to be the minor segment. Ne? Thank you. Nangwakho a moderator, namuyasiphaphela. Inhloko yakhe ayisebenzi, kweli dust. Bani lo? Thank you. Inhloko yakhe ayisebenzi lo. Kweli dust. Angazi ukuthi uzowathenda ubani ngo-9. Inhloko yakhe ingasebenzi kahle. I wonder when someone say for tech, when you say thank you very much and God bless you. Ne? You say thank you very much, God bless you, my friend. God will deal with him. So, do you offer on? Yes, I do offer online classes. We will talk about that. Ne? So this one is the major segment. This one is the minor segment. So now, what is this line now? The line from this from the circumference to the circumference that passes through the center. What do we call that line? Thank you very much. It's gonna be the what? The diameter. Ne? It's gonna be the diameter. It's gonna be the diameter. So now we are clear in labeling the circle. We are clear in labeling the circle. Ne? I don't want to dwell. I don't want to explain things like what you call things like theorem 1, theorem 2, theorem 3. No. We are not gonna do that. I'm going to give you a strategy of remembering the theorems. Ne? The strategy of remembering the theorems. Which one is the diameter? Is the line from the chord, like the diameter it's like a chord, ne? Just that it passes through the center. It divides the circle into two halves. Ne? The diameter, it passes through the center and it divides the circle into two halves. Ne? It's like cutting the orange into half. This is the center line. Are we clear? Are we clear on that one? Ne? Are we clear on this one? Are we clear? Are we clear on this one? Thank you. Thank you very much. Thank you very much. So can I move now? Can I move now? Can I move? Can I move? Can I get a thumbs up? Do we move now? Do we move? Do we move? Do we move? Yes. Thank you very much. Ne? The only way I do only native courses and courses. I don't do degrees. What about the second? Oh yeah. Thank you. Ne? Yeah, thank you very much. Thank you very much. So we have this guy, ne? This guy. Just that I didn't draw him into scale, ne? This guy, which touches the cycle at one point outside, ne? Yes, that one I do. This one is going to be the what? The tangent, right? So this guy is the line that touches the circle at one point, ne? At one point, right? At one point, right? Thank you. And we are going to have the sector. And the sector, I won't talk about it because of it is useless to us. I won't talk about the sector. Ne? It is a sector. That's why I'm saying what I won't talk about that one because of it's useless to us. What do we use secant? In which theorem do we apply a secant? It's useless for us to talk about it for now. Ne? So let's move. But the tangent is very important. The tangent is important to know the tangent. So now let's try and remember the theorems that includes the center. Ne? That's how we are going to remember all these theorems and how we are going to identify them. Ne? I don't want you to remember, oh, theorem 1, theorem 2. No. I feel like it's old school, this one. Theorem 1, line from the center, perpendicular to the chord, bias RA. No. Theorem 2, the line from the center, what, the angle at the center. No. We are going to talk about the theorems that includes the center. Center. Hey, help me with the spelling. Included. Center included theorems. We have this theorem. Aha! Do you recognize this guy? Do you recognize this one? How many? With the raise of a hand, how many who recognize this guy? Recognize. Yes. Thank you. Do you recognize? Thank you. Ne? So now, yes, you will tell me. It's fine. I will be fair to you. You will tell me what is this theorem. It is center included, right? Thank you. Perpendicular to the chord or line from the center to the midpoint of the chord. Ne? So what is this theorem tells us? It tells us, like, if you have the line that is from the center to the chord, and they are formed when we are having a perpendicular line here. The line, the center, if we have A, B, or let me just say A, B, C, and O. So if we have O, B being perpendicular, ne, to AC, we are concluding that if OB is perpendicular to AC, therefore AB is going to be equals to BC. Reason, guys. Reason. The line from the center to the midpoint of the chord is perpendicular to the chord. Or the line from the center which is perpendicular to the chord, it bisects the chord. But I'm going to prove this theorem before we are talking about lots and lots of things, because of I can see, ne, you have to be careful because this theorem, it goes in two ways. Ne? It goes in two ways. We are having this scenario, ne? We are having this scenario, and another scenario that we are going to have these guys. Hey, my cycle. A, B, C, and O, and go, ne? Then I'm going to say if A, B is going to be equals to B, C, and therefore A, C is going to be perpendicular to O, B. So do you see how it goes in two ways, this theorem? Do you see, Hore, this one? How about you say A, B, and C, B? I know. Why given? Who gave you that one? Who gave you that one? Or maybe this one, or you mean this one, it can be given, ne? It's fine. Yes, this one can be given, and this one it can be given. I gave you that one. Ne? Ne? I gave you that one. So it's fine. Even the given reason is very important. But yeah. Yes. So now we are going to prove it. We not yet know. We don't know. Or these two, they are applicable. What's wrong, Claudio? What's wrong? What's wrong? What's wrong, Claudio? Elele, good meeting. Thanks for joining my session, my friend. Yeah, morning, my friend. No, morning, my friend. How are you? How are you? How are you? So, guys, we are having this and that, ne? Like, why am I drawing the two, ne? I know, hore, I have to state the reasons. I have to do what, and what not, ne? I want to show you, hore, you have to be careful on your reasoning, ne? You have to be careful on your reasoning when you're dealing with this guy and when you're dealing with this guy. So, on this guy, what reasoning are we going to use this guy? Can I have this? Are we providing? Yeah. We are providing knowledge. We are sharing the information with the black relation. What's between the chord and the circumference? What's between the chord and the circumference? What do you mean? Can you please specify there? Guys, I can see all the on the comment section. I was trying to make sense out of whatever that you are talking about, but so you think or they're the same, or maybe you think that they're the same. If you think that they're the same, come forward so that we can see you. But I'm telling you, the reasoning is different here. Ne? The reasoning is different. How can we reason for this one? How can we reason for this one? Let's check scenario number A and give the reason for scenario number A. Let's give the reason for scenario number A. Relax with the congruence. We are coming. Yes. Here. Thank you. No, we are not proving, guys. Listen to the question. We are coming with proving. We are going to prove. Relax. This. Hey, linguistics officer and what? Onya. Linguistics officer. Yeah. Linguistics officer. What? Onya. So this one, it has 90 degrees, ne? The line drawn from the center perpendicular to the chord. Ne? Check the statement. Why? You will see why I drew these things. The line from center. I'm not sure this is the spelling of the center or that one is the right one. I'm not sure. Perpendicular to chord. And when we come to this one, line drawn from center to the midpoint of the chord. Ne? Here, line drawn from the center perpendicular to the chord bisects. Here, line drawn from the center to the midpoint of the chord is perpendicular to the chord. Here, it bisects the chord. So do you see? The reasoning is not the same, guys. We are tired of losing marks over unnecessary things, guys. Unnecessary things. Unnecessarily. I mean, they must be long. Yes, it's acceptable. This is perpendicular. I don't know, but I will provide on my next lesson. I will screen record my PC and show you the acceptable reason. I have a document for it. Ne? Here I'm just providing the concept because it's gonna be boring if maybe I refer, I teach, I refer, I teach, I refer. But it's your duty to refer to the acceptable one. Ne? But these ones that are along those lines. I don't want to wait. Then I go no. So guys, basically here, I'm just showing you the difference between two reasons. Yes, thank you for that. Thank you for that. There is an exam guideline, guys, which is acceptable for these reasons. But what I was trying to show you, you can be given a scenario with a perpendicular, because some people, they will do what? They will take one reason. Maybe they will take this, if this is perpendicular, and this, you will link it with this reason. This, it doesn't fall under this reason. This one, it has its own reason. This one, it has its own reason. That's why I separated the two, so that you can see. So that you can see that, yes, I believe after Euclidean do meet, but this one is gonna be a long one. So after this one, you can see where the line drawn from the center to perpendicular to the chord. I'm specifying the line drawn from the center perpendicular to the chord. You can see where this is the line drawn from the center perpendicular to the chord. What does it do? It bisects the chord. It bisects the chord. The line drawn from the center to the midpoint of the chord. You see, where's the midpoint? Here's the midpoint of the chord. Is perpendicular to the chord. This whole thing, it describes theorem 1. China, bafethu. Am I talking Chinese? Am I talking Chinese here? We are tired of people losing marks unnecessarily. Because why am I doing this? I'm emphasizing this because of why. People, you can be still given a mark. It doesn't mean this, it goes with this reason. This one, it goes with that reason. You don't mix them up. Because the moment you're saying, if you are given a line drawn from the center perpendicular to the chord, and on your reasoning you say line drawn from the center to the midpoint of the chord, where is the midpoint here? Where is the midpoint? I can't see the midpoint. Where is the midpoint here? There is no midpoint, but there's a line that is perpendicular to the chord. But when you see this scenario, you want to use this reason because of you crammed. You shouldn't, guys. Don't lose marks unnecessarily. Guys, do we move? Like, I hope I'm saying this for the last time. These two reasons, they are going individually. So this one is for this one. This one is for this one. Don't mix them. Don't cram this one reason or okay, this is the reason for theorem 1. These reasons, they are applicable for both. No, that's the catch there. You'll be catched and you'll cry alone or blame a system. You are not late, my friend. You are not late. You don't blame a system or one rupee and about roba. By not being strategic in terms of reasoning accordingly. Because you can take this scenario and you say line drawn from the center perpendicular to the chord. There's a perpendicular line here. Tell me, There's a perpendicular in this diagram. There's a perpendicular. Yes, no. There's a perpendicular here. There's a perpendicular here. Yes, there's no perpendicular, but there's a what? There's a midpoint. So you have to specify. You reason to according to what you see. Line drawn from the center to the midpoint of the chord. Line drawn from the center to the midpoint. Where's the midpoint? Here's the midpoint of the chord is perpendicular to the chord. Then after this reason, that's when you have the right to put your 90 degrees like that. Here, after this reason, that's when you have a right to put your whatever. Hey, what do you call this? Hey, I don't know. What do you call this? Your lines indicating what AB is going to be equals to BC. Ne? Is that clear, guys? Now we're about to prove this. Is that clear? Can we move? Yeah, I'm a line. Yes, equators. I'm a line. I'm a line. Thank you very much. Thank you very much. Now let's go to proving. Guys. It means AB is going to be equal to BC. No, yes. After this reason, you are going to conclude now AB is going to be equal to BC. After this reason, that's when you can conclude O angle BC is going to be equal to 90 degrees. One of the theorems which includes the center. So let's do it. Let's prove it. And guys, math is a language. Ne? Math is a language. You have to talk with maths. You have to talk. So let's prove now. What is the first thing that you do? Those who knows, what is the first thing that you do? What is the first thing that you do if you are proving this theorem? What is the first thing that you need to do in order for you to prove this theorem? Yes, you are going to do the construction. Ne? You are going to do the construction, and even on paper you are writing it. Let me use this space. You're going to write this. One first time you're going to write this. What are you going to write? You are going to write construct. Now I'm telling the examiner, the person who is marking the paper, you are saying, or construct. What are we constructing? What are we constructing? What are we constructing? Okay, I see, Hori, a lot of people. Yes. OA and OC. What is the purpose of constructing? Let's teach each other. And you don't just say construct radius. You can just say, sometimes you can say OA and AC. Or some people, they will say construct radiuses. No, you can't just say construct radiuses. No. You can just say construct radius OA and radius OC. Thank you, Charlie. Thank you. So that we can prove using congruency. And guys, you should be yes. Thank you, Juicy Kid. To find the common between to find the congruency. Ne? Construct. Well, I will just leave it like this, but I will just confirm by telling you, you construct OA and AC so that you can be able to prove. Oh, sorry, OC. Thank you very much. Thank you, Brika. Thank you, my friend. Thank Thank you very much. OA and OC. OA and OC, guys. Thank you, Liso. I saw you were trying to correct me. Thank you. And CP, thank you, CP. I believe your name is Spacely. And AC, right? Right? You are constructing OA and OC. You get it? You get it? You are constructing OA and AC. So that, what is the purpose of constructing, guys? Ne? The purpose of constructing, you want to prove the congruency between two triangles. Let's help each other here. What is the meaning of congruency? What is the difference between congruency and similarity? And first question, is it necessary to contrast using dotted lines? Nah, it's not necessary. Even though you construct using a pencil, because the pencil is erasable, right? Why are you proving this if they are enabling you to construct? Why do you have to say dot dot? Mara, it's fine. It depends on you. It depends on how you were told. But even though you do it with a pencil, askeri are proving. It's a triangle, Mus. You told me, Hori, you're constructing OA and LC. Don't be scared. Zui. Exactly the same mean congruence. Let's not use the exactly the same, because the same falls on similarity. Mara, I get you, Lindy. Congruency mean two triangles that are equal. Yes, congruent, identical. Similarity, it's proportional. Yeah, I wanted that, ne? Because of we can be similar, but we can't be identical. Like identical twins. And like you and your brother might look similar, but not exactly identical. So here we want to prove for these two triangles, they are exactly the same. The nose measurement is the same as the right nose measurement. The eye is positioned on the same eye. Like everything here has to be identical. When I'm looking at OAB, I'm looking at OCB. Ne? Guys, we are tired of losing marks unnecessarily. We are tired. So now, what are we going to do? Guys, be careful. You don't just come out of nowhere. And say, what is the first statement of proving congruence? What do you say on the first statement? Proving. Ne? You're just going to say proving, and you come out of nowhere because of when you want to prove congruence, and you come B O C is congruent to O B C. No, you don't do this, because the moment you do this is wrong, guys. Why is it wrong? This thing, why is it wrong? Tell me, why is it wrong, this thing? Can someone come forward and tell us? Given it's necessary. Why is this format wrong? I'm talking about this statement here. Why is it wrong? No, it's not the same. It's not the same, guys. Ne? It's not the same. Ne? People. Okay. Thank you. Thank you for commenting and participating. Ne? Guys, in maths, ne? You have to have the third eye. And can you please get me into 20K? I'm gonna tell you why. In maths, you have to have the third eye. And that third eye, it has to see the unseen. Ne? You have to have the third eye. And what do I mean by the third eye? B is not equals to O. Let's see. B is not equals to O. Ne? Basically, you are writing this format in such a way that it has this B, angle B has to be equals to angle O has to be equals to angle B, angle C has to be equals to angle C, BO has to be equals to OB, OC has to be equals to BC. So this format is wrong. What you are proving, you are proving, and whenever you are going to prove, you have to assume those things that are already congruent. That's why you are saying proving, and you can tell A is going to be equals to C. You are going to say proving triangle A. This the first triangle. You can write it wherever that you want to write it. You can write it wherever, wherever, it doesn't matter. But the second triangle, it has to correspond with the first triangle. Guys, don't lose marks unnecessarily. Don't lose marks as... Thank you, Omolemo. Thank you. You're on the right track. You're on the right track. But don't lose marks unnecessarily. That's why I'm having the triangle. Thank you, Ria. Thank you, Ria. Keep on coming with them. Don't worry. If you know the answers, keep on coming with them. So I'm going to start maybe by saying A, O, B. Ne? Is gonna be congruent with, I know, I'm assuming now. A is gonna be equals to C. I know it's gonna be C. Ne? And obviously O, it has to be equals to O. Ne? Let me say O1 and O2. O, it has to be equals to O by saying it, because of they have to be congruent. And we are assuming, but we are writing it in the right order. So O has to be equals to O. So it's going to be C, A is positioned here, and C is positioned here, and O is positioned here, and O, another O is positioned here. So I'm going to have the O there. And again, I'm going to have my B being my 90 degrees, and the B being the 90 degrees. Let me say B1 and B2, and CO, B. It doesn't matter. As long as it corresponds. AO, it has to be equals to CO. Are they equal? I didn't write anything here. I didn't write anything. I want to show you the format. How is it important? Are they equal by looking at it? AO is it equals to CO? Is it equals to CO? Are they equal? All right. Thank you. Let's look at OB. Is it OB equals to OB? The way we've written it with the format. Is it OB equals to OB? Thank you. Okay, it's fine. Is it angle A being equals to angle C? By looking at it, before we go to the reasoning, before we go far, guys. Before we go far, are they equal? Angle A and C, are they equal? By looking at this. By looking at this, are they equal? Guys. You see, Euclidean geometry, it's nice, guys. It's nice. And angle O, okay, angle O, we can see, okay, it's fine. But let's see angle B. Angle B, is it positioned in the last angle? And angle B, are they equal? When you're looking at the triangle and looking at the format, are they equal? By looking at this, are they equal? Thank you, Butato. Thank you very much, my friend. Thank you very much for the gift. Are they equal? You see, you are done. Like, you are absolutely done. You are done. Thank you, Ditewoho. Thank you very much for the gift. Really appreciate it. You are done before you even started. Before you even started, you are done proving. Bafethu. Man. Man. Yeah. Hey, join my team. Thank you very much. Ditemo. God bless you. I'm hoping that this lesson, it gives you the eye opener. It gives you the eye opener. You see, you are done with, even you didn't start by proving, but you are done proving. You are done proving. Guys. Now you are doing what? You are going with your paper that you are going to submit. You are writing now. Proving. Already you've proven. And you have to prove 3 things. Only 3 things. Guys, thank you, Butato. Thank you very much. You are proving 3 things. Only 3 things that you have to prove this. To prove for both triangles they are congruent, you have to prove only 3 things. 3 things. Not more than that. Don't say A is equals to Y. No. How you prove congruence is similarity. Similarly with similarity. You are proving 3 things. 3 things before going far. So you are going to say, okay, you already know with your format in here. You say AO is going to be equals to CO. Resin, AO, CO, you come back to your diagram. You know already, Radi. Ne? Okay, sorry. What is the resin here? Is it Radi? Yes, you can go to the toilet. Radi. Ne? And already, O and O, okay. You can see O and O, you can't say a resin. You see it and you dodge that part a little bit and you will just see what? Angle A is going to be equals to angle C. Resin, what is the reason for that? What is the reason for this one? A is going to be equals to angle C. This is another one where people get chowed. And I don't like it, guys. Guys, I need... Jamlut, welcome back, my friend. Why is the A equals to C? I want to see the comment section. I'm interested in the comment section. Yes, Yachi, I see you, my friend. People, why is A equals to C? Why is A equals to C? Oh, Yachi. All right. Sorry for the false. Okay. The reason is going to be angles. Opposite. Ne? Angles. Opposite equal sides, guys. It's an isosceles triangle, but we don't use the isosceles triangle. So what are we going to see? We are going to say angles opposite equal sides. The angle is opposite to the equal side, and this angle is opposite to the equal side. It is the angle opposite equal side. Guys, come on, guys. Yeah? This angle is opposite to this side, and this angle is opposite to this side. So it's going to be angles opposite equal sides. Ne? The angles that are opposites to equal sides, they're equal in full term. If they didn't tell you, if they've been telling you to cram me, I'm telling you to know it. Or the angles that are opposite to equal sides, they're equal. That's why they're saying angles opposite equal sides. Thank you very much, Corey. Thank you very much. God bless you. God bless you. Ne? So you are going to have what? You are going to have angles opposite equal sides, ne? But don't write it the way I've written it. I'm not sure this is acceptable, but I'm just going to explain it in simple terms. You can see what this C is gonna be equals to AO, and AO is gonna be equals to OC. And guys, be warned, ne? Be warned. Oh, thank you, Chloe. It means what it's acceptable like that. So be warned, ne? You can't just say this is equals to that without letting me to know. Jamblu to 10. Which is incorrect if you say. The opposite to one side. No. Jamblu. No. So be warned, guys, ne? Thank you, slash V1. Thank you, my friend. Thank you very much. So be warned, guys. You can't write angle A is gonna be equal to C without saying what you have equal sides. You have to confirm what this side is equal to this side before confirming the angles. It's 12 o'clock, my dear. 12 o'clock. You can't confirm the angles are equal without telling us the both of the sides they are what? The both of the sides they are what? They are equal. Aye. Sasebenza manje. Sasebenza. So what else that is left? What else that is left? Give me what is left. Give me what is left. What is it that is left? Asebenzeni bafethu. Give me what is left. B is gonna be equals to B. Or OB is gonna be equals to OB. Ne? Yeah, that one of OB is gonna be equals to OB. I prefer it. Ne? I prefer that one. OB is gonna be equals to OB. I know this B is 90 degrees. I know this B is 90 degrees. So I prefer OB to be equals to OB. Ne? I prefer that one. Ne? Because of why? The sides are common. So OB is going to be equals to OB. Reason, common. This is one line. Guys, don't cram. Common. What is common? This is the common line. Two triangles, they are using the common line. That's why we are saying this thing is common. Guys, I don't like teaching things people they don't understand. So what is the statement? Therefore, yes. Mara, guys, when you are proving congruence, just three things you need to do in order for you to confirm that this and that, they are what? They are equal. Ne? Yes, the last statement, therefore, ne? Triangle AOB is gonna be congruent. Ne? I know matrix, they are used to similar. Congruent matrix, congruent. Ne? This is for congruent. We are not similarizing here. It's congruent. Don't be confused. I know, yeah, we did that one. So we are going to come to the similarity one. Ne? OAB is going to be equals to COB. Reason, the reason is going to be what? What is going to be the reason? Can someone give me the reason? Thank you, Dipros. Thank you, B. Thank you. No. Don't worry. You just need three things. Ne? You just need three things. Three things. Ne? You just need three things. three things. Ne? Even though I can't say, oh no, this one is gonna be, doesn't matter. As long as I proved three things. Ne? So what is the reason is going to be side, angle, side. Asker, is that what you've proved? No. With the 90 degrees, we are going to include it if we talked about it. But in this case, we didn't mention any 90 degrees. That's why we are saying what? Side, angle, side. Side, angle, side. Guys, the order is very important. The order is very important, guys. The 90 degree, you're going to write it if we talked about it. Ne? If we mentioned B2 and B1, they're the same. That's when we would have said 90 degrees, angle, or whatever side. But this time, we didn't talk about the 90 degrees. So we are going to say side, angle, side. Be careful. Be careful. Be careful. And you are not done, guys. Bear in mind, guys. That's why I'm very slow in this thing. That's why I'm very slow. That's why I am very slow. You are not done. Ne? You are not done. Ne? You are not done when you are here. Remember, we are not proving the congruency. We are proving the theorem. This theorem, the line drawn from the center perpendicular to the chord, it bisects the chord. That's what we are proving. Ne? That's what we are proving. But, and it brings another idea. Ne? It brings me another idea. It brings me another idea. Maybe we should include the 90 degrees here. Ne? What do you think, guys? Should we include the 90 degrees so that we can make sure the examiner, he sees no, man, we are talking about the 90 degrees. We are proving the 90 degrees. Should we include it? What do you think? Should we include it and replace this guy, OB, ne? The common side, ne? Should we include it? What do you think, guys? Because remember, we are proving that line from the center being perpendicular to the chord, it has to bisect the chord. So maybe we should include it, ne? We should include it, ne? We should. But yeah, I think it's not necessary. I think it's not necessary. Because already, yes, I think it's not necessary, ne? Because already, if we can say this side angle side, we've proved that these two angles, they are congruent, ne? Guys, thank you very much. I don't think it's necessary, ne? Because of the moment you prove for these two that congruent, and beneath, you can just say B1, angle B1 is going to be equals to angle B2, ne? Beneath. Asker, you are done proving. You are done proving. Here you can just say B1 is going to be equals to angle B2. Reason, it can be proven, or maybe you can also say angles at the straight line, or maybe proven. You're still correct. Because this, it's proven. Ne? You can just say B1 is going to be equals to B2. This is proven by the congruency, and you can just say AO is going to be AB is going to be equals to CB. Ne? AB is going to be equals to CB. Reason proven. Are we done? Are we done now? Are we done? Are we done? Where are you lost, my friend? Where are you lost? I think we are done. Ne? Are we done? Yes, because of this one, B1, it's going to be B2. Or you can say proven or both equals to 90 degrees. This one, it's important. I believe, or this statement, it's important. Because you have to indicate, or this angle, this line drawn from the center, it's indeed perpendicular. Or maybe this line drawn from the center, it's indeed perpendicular. Or it's given. And it's even given. Do we have a right to write X? Pere ke sa phela mpona ke nonne brawa o re o irala hey 602 was my what explain from where Clinton I wonder if you don't become, we can write it's given or both equals to 90 degrees, ne? We are moving. Yes, if it's given, then we can confirm this one equals to this one. It's proven. So are we clear? I want to move to theorem 2. Thank you very much. Thank you. Or you think with this one I should remove it? But I want us to be clear with everything, guys. AB congruent to CB. AB. What's happening? Come with them. No. 90 degrees is not important. Remember, triangles, beats, all corresponding. Yes, thank you, Jamlud. That's what I was thinking too, ne? That's what I was thinking too. Remove the common. If we remove the common, let's say we have removed it. That's what I was thinking too. That's why I was looking for your feedback, Hori. What's happening? Is this the is this the correct way of proving theorem 1? Or we should include this 90 degrees? Or maybe this statement is it's not, which means yes, I do have a YouTube channel. So you want me to replace this one? Because this one and that one, I can remove it and say, hore, B1 and B2, they're both 90 degrees or given or whatever. So it's going to be 90 degrees angle side. The reason here is going to change here. It's going to be 90 degrees angle side. Why? But one thing is perpendicular included, which means 90. Yes, toxicated. You are very correct, my friend. They are all equal, but one thing is 90 degrees. Yes, Mara, if congruency, if guys, let's talk sense. Like, let's logically see this, ne? Because me, what I'm thinking now, ne? What I'm thinking now, if congruence is proven, automatically I'm saying B1 is equals to 1 degree. I want a TikTok now, it's starting, you know. Wow, man. Ish. I want a TikTok, you know.
I-O-Q-U-D.
I-O-Q-U-D. Wow. Ish.
X-G-Z-U-K.
X, Z. Oh. X, D, Z, U K. Eish. Awa. Kanti?
M V W T N.
TikTok. M V W C N. Hawa.
N B M A G.
N B M A D. Oh.
K W R X V.
Yeah. How?
A L D O T.
A L D O T. Yeah. Kanti. Ay. Hey. This thing of TikTok. Kanti, guys, you are able to hear this thing when it does its own thing. You are able to hear. Oh, I'm able to hear. Me, I feel like what this thing I sometimes says. But it's fine, guys. Like, let's move. Right? Thank you. So, guys, Mara, this is the way. Congruency. You can even include your 90 degrees and you say 90 degrees angle side. But what I was thinking, Gori, the moment you are done proving or both of these angles, they are congruent, it means that also B1 is also equals to 90 degrees. Or am I wrong? Because if this one is congruent with that one, it means that B1 is also 90 degrees. It means that O2 is going to be equals to O1. A is going to be equals to C. It means that now it confirms that this is the line from the center to the midpoint of the chord. And now, according to this, A, B is going to be equals to C, B. Do you see it? Do you see it? Do you see it? Yes. So guys, on our next lesson, because I want to move to theorem 2, on our next lesson, we will correct each other in terms of this one. Can you please? Yes, as you dig. Thank you very much for the rose. Thank you very much, my friend. Thanks for your support, my friend. So on our next lesson, I want to prove theorem 2, because we can't stay on this because of why the time is running and we still have a lot to do. I didn't even get to touch the question. Yes. Oh. Life ingenzani. Life ingenzani. Ayifuna ukuthi sifunde bafethu. Nemali ziyadlula la, Wizwile moderator. Marina flow. Center included lines, guys. Remember, we are still on the center included theorems. So go. Yeah, ne? We are still on the grade 11. We're still on the grade 11. Yeah, ne? O and M. So why finally? Don't worry, we are ending while it's done, but not anytime soon. It's gonna end, but they're saying finally. What is finally? Or maybe you're waiting for it. Euclidean. Yes, you're Euclidean. We are here. We are here now. We are finally here now. So guys, this is another center included. Eh? This we're on the center included. Ne? Let me just say this one is A, this one is C. How do we see how this one is a second one? Ne? Can it's theorem what this one? According to is theorem what? Is it theorem 3? Because I remember for this one it's a center included also. It is theorem 3. Okay. Yes, it's gonna be theorem. Because some people they are saying it's 2, some people they are saying it's 3. Kanto, what is theorem 3? Gana, what is theorem 3? Or what is theorem 2? Is this one theorem 3? This one is theorem 1. I forgot, guys. Please help me on this one. This one is theorem what? This one is theorem what? This one is theorem what? Is it 4, this one? Oh, this one it's 3. And this one it has to be 2, right? Yeah, okay. This one it has to be 2. I believe for this one it has to be 2. But it's fine. As long as you recognize this, or this it's part of the things that you have to do, we are still going to have to prove it, né? And surprisingly, guys, you have to prove this thing. And how do you prove this one? Let's start with the reasoning, né? What I know is this angle at the center, it is 2 times the angle at the circumference, né? It is 2 times the angle at the circumference. Yes, thank you. The angle at the center, it's 2 times. It is 2 times. Yeah? No. But when you say it is 2 times at the circumference, it becomes the different context. It becomes the different context. So, and guys, I want to emphasize something, man. Yeah? Stop following and unfollowing and following and unfollowing, because we see there are some people they will makata you. Yeah? You follow, then later on you know where they unfollow. Babo? Start the equation. Is this an equation? Is this an equation? Yes. We are going to start with the reasoning. Yes, the angle at the center, it is 2 times the angle at the circum. Is this reason acceptable? Is this reason acceptable? Or we have to write it fully? Like with weights, the angle at the center is equals to the angle at the circumference. Is this one acceptable? Oh, who do we need the reason with that? Alright, thank you very much. Thank you very much. Ne? Guys, it is advisable for all of you to go through your exam guidelines, ne? So that you can see that which reasons are acceptable and which one are not. Ne? Yeah, I have to buy different color pens. So thank you. So now, what is the first thing that I have to do? Those who know, what is the first thing that I have to do? Ne? What is the first thing that I have to do? What is the first thing that I have to do in order for me to prove this one? What is the first thing that I have to do? Going once? Construction. Be specific with your construction. Be specific with your construction. Ne? Guys, ne? Whenever I'm writing this reason, I'm not saying whenever they ask you to prove, you have to start by reasoning. You can't prove something and you can't have a reason for something that you're about to prove. It doesn't make sense. Ne? Let's try and make sense out of mathematics. Ne? We are going to construct MO. Okay, let me construct MO. Askiru are telling me to construct MO. Ne? Let me move this one and put it on the side here. Let me construct MO. Yeah, I've constructed MO. Let me do it with the blue one. Here's my MO. Do we construct like this? Askiru, you said I must construct MO. Yes, I constructed MO. Do we do it like this? Askiru, you said I must construct MO. You see the language? The language, it's very important. Ne? You have to know the RTP, what is required to prove. You have to know the RTP. Ne? The language is very important. You have to say, thank you, thank you. You have to say, let's go back to our script. You have to say construct. Ne? Construct MO to produce. What letter can I use? Yeah, B. That's the first letter that I saw in the comment section. To produce B. You have to extend your line in such a way that it becomes here. Or it doesn't matter. It can touch the circumference or it can end just here. We just lead this line to produce B. Ne? To produce B. Guys, is that clear? Is that fine? Is that fine now? Is this clear? Is this clear? Is this clear? Whenever they're asking you to prove this theorem, you have to construct MO to produce B. You don't just say construct MO, guys. Hey. No, man. You guys, you get unnecessary wrongs, guys. Don't just get unnecessary incorrect. I'm Frostan. I'm Frostan. Thank you. Without the construction line, it's C. What is C for? Guys, do I need C? Like, can I ask? Do we need C here? Like, do we need C? Do we need what is it that we need to construct C4? Required. Yes. Oh, yeah, I think Rana, you have a point, ne? I will emphasize that, my friend. You have a point. Required to prove. Yes, you have to write RTP. Yes. You have a point. You have a point, my brother. Required to prove, then you write the reason, ne? I think that's what you are talking about. Yes, RTP. But I want, like, I see the C here. What is the C for? Come forward when we see. Come forward. We see. See, come forward. Ran away. Let's continue. So, guys, we are having M1 and M2. Ne? I'm sorry, guys. I have to be slow. Because, hey, people, they're getting unnecessary incorrect answers, so they have to, like, even though you are going to watch my YouTube channel, you will see because this is recorded, ne? This session is recorded. I have to be as accurate as possible, allowing all the questions to be asked and answer as far as possible for my YouTube channel to be as accurate as it is, ne? Like, I know there are some people, they want us to do va. But we will get to that point. After this video, I'm not going to numbers. So, guys, Jessica, sorry man. You can answer the question. Moderator, can you please bring Jessica forward after writing? You can write your question. So, guys, construct MO to produce B. Now we have O1 and O2. Ne? Now, what concept are we going to use? We are going to use the concept of straight lines. Ne? We are going to use the concept of straight lines. No, of the exterior angles of the triangle. Ne? The exterior angles of the. Can we say construct the line from MO? Emma, can we say construct line M through O to B? Just say construct line M. Hey. Hi, my friend. I'm not sure about that one. I'm not sure. Through O to B. It makes sense, but I never saw something like that before, my friend. Jamlut. Please adapt to this one, ne? Mara, or consult. It makes sense. Yes, it makes sense, but please adapt to this one, or maybe ask your teacher. But it's your reasoning, ne? It's your reasoning. As long as it makes sense, I think it is acceptable, because of even a person who is gonna mark there is not a machine, is a person. He's going to read your script and he's going to say, or no, you constructed MC through O. Or maybe you can say construct the diameter, or maybe construct the diameter MOC. Ne? You can say construct the diameter. I suggest, or you say, I like to advise people to construct the diameter MOB. MOB. Ne? I think it's going to be easy like this, ne? To make, you can even say this, it's still acceptable. Construct the diameter MOB, finish, you are done. Unlike saying to produce, just to make the English to be fancy. It's unnecessary English which we are using here. Even this one, it's unnecessary English which we are using. But it's fine. Let's use B. So, the first thing that we are going to do, we are going to say OM is going to be equals to OA. We are going to say the first statement that we are going to write, we are going to say MO is going to be equals to OA is going to be equals to OC. So what is the reason for this? What is the reason for this? What is the reason for this? Yes, K star. K star. What is the reason for this? Not radius. Ready. Tletse ka o dlala wena. O tshale ka 12. O tshale ka 1 ya boshigo. You don't have to say equal radius. When you say radi, it means all the radiuses are equal. Wabo? So we are going to say radi. So another thing, what are we going to say? We are going to say O1, ne? The O1, ne? Or maybe let's say M1 is going to be equals to what? What is M1 gonna be equals to? Okay, it's just that like my screen is limited, guys, ne? Oh, when I'm standing here, yeah, it's going to be equals to A, ne? What is the reason? What is the reason? Thank you. What is the reason? What is the reason? No, Maskandi, don't rush. We are going to come. We're going to come there. We don't worry. What is the reason? No, not isosceles, guys, not isosceles. Yes, angles opposite equal sides. Ne? Yes. Angles opposite equal sides. So what else? M2 is going to be equals to what? What is M2 gonna be equals to? What is M2 gonna be equals to? Thank you very much. Let me bring this closer. Thank you. M2 is gonna be equals to angle C. It's going to be angles opposite equal sides. Ne? So again, what are we going to be having? Now we want to do what? Ne? Now, there's a critical statement that we have to make now. Ne? Do you agree O1 is an exterior angle? Do you agree O1 is an exterior angle? Can I have a yes, no? Do you agree O1 is an exterior angle? Thank you. So we are going to say, let's start with O1. Ne? Let's start with O1. So O1 is going to be equals to what? What is O1 going to be equivalent to? Since O1 is an exterior angle. By looking at the diagram, what is O1 is going to be equivalent to? Thank you. It's going to be M1 plus A. Oh, sorry about that. M1 plus A. But we are still on the case here O1. We are going to say since we confirmed that M1 is equals to A, ne? Angle M1 is going to be equals to A, therefore O1 is going to be equals to M1 plus M1. Therefore, angle O1 is going to be equals to what? 2M1. Are we clear on this part? Which reason? Oh, this one. The exterior angle is over triangle, the exterior angle of a triangle. Guys, you have an exam guideline, guys. I told you, whenever I start this life, I told you, Hori, the reason that doesn't have to be as accurate, because I can't go and refer and look for the right answer. Or maybe what I'm talking, angles opposite equal sides. No. Let's Rana, let's come back here, guys. How many of you can with the raise of a hand, how many of you are familiar with this reason? Ne? How many of you are familiar with this reason? Or maybe no, not the exterior angle. This one. Angles opposite equal sides. So is it acceptable? Yes. This is the reason that they are using, Mr. Rana. This is the reason. Even I know this one. For equal angles, if you are having angles of a triangle, this angle or this angle and that angle being equal, right? This side and that side, they are equal, and the angles opposite angles of a triangles. Basically, they are saying opposite angles, equal sides of opposites, equal angles of opposites, angles that are opposite to, angles that are opposite to equal sides are equal. You understand? Inside a triangle, angles opposite, angles that are opposite to equal sides are equal. Yes, this is what it implies. So here we are clear, guys. Here we are clear. Are we clear? Are we clear here? Thank you. Thank you. Thank you very much. Thank you very much. So now let's go to the case of this one, O2. So what is O2? What are we saying on the O2? So on the O2, what is O2 equivalent to? 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 Thank you. Thank you. It's going to be M2 plus C. O2 is going to be equals to M2 plus C. But since what? Since what? Since M2 is going to be equals to C, ne? Since M2 is going to be equals to C, therefore, we are going to have O2 being equals to M2 plus M2. Then O2 is going to be equals to 2M2. Once we are here, guys, once we are here, I'm telling you, once we are here, I'm telling you, because the last statement is what? What is the angle? We are going to look for the angle. This angle, ne? This angle. What is this angle equivalent to? Can we write this angle in terms of O1 and O2? This angle here. In terms of O1 and O2, how can we write it? This angle in terms of O1 of O2. Asker, this angle is the one that we are proving, or it is 2 times that one. Anger, can we write this angle in terms of O1 and O2? Can someone give me that? No, in terms of O1 and O2. O1 and O2, guys. Oh, listen to the question, guys. Listen to the question. This angle in terms of O1 and O2. Because here you are presenting, how can you prove this is 2 times that? Anger. Thank you, thank you very much. Ne? O1 plus O2. This angle is the one that we want to prove that it is 2 times the angle at the circumference. Ne? Do you see it? So now we are going to be equal sign. So we are going to write this on our right hand side, but with the order. What is O1 equivalent to? What is O1 equivalent to? What is O1 equivalent to? Can you see what O1 plus O2 is going to be this full angle? Do you see it? Yes, no, yes, no. Do you see it? Thank you, say Waterson. Do you see it? Or O1 plus O2 is going to be this full angle, right? So since it is equivalent to this full angle, this is going to be equivalent to what? 2m1. 2m1. So what is O2 equivalent to? And this plus will follow. What is O2 equivalent to? What is O2 equivalent to? Yes, it's going to be 2m2. Then what do? O1 plus O2. You are going to take out a common factor. The common factor of 2 to show. I'm going to take out the common factor of 2 plus m1 plus m2 to show that this angle, you can see now, if we are comparing this statement with what you are implying to prove, it makes sense now. Because now you are going to do what? You are going to say O1 plus O2, is this angle at the center. Do you see it? This is the angle at the center. Is equals to 2 times the angle at the circumference. Is the angle at the circumference O1 plus O2? Is the angle at the circumference O1 plus O2? Can I get a confirmation? Can I get a yes, no? Is it M1 plus M2 at the circumference? Yes, no? People that scared to answer. I don't know when you say no. I don't know. I should speak Chinese, eh? Maybe I should speak Chinese for you to hear me. Or maybe uyawudlala ka 1:30. Uyawudlala ka 2. Wadlala wena. Yeah, Jamlut. You can do it. We are proving the theorem. So we are done, guys. You have proved already O1 plus O2, which is this angle. It is 2 times 2 multiplied by M1 plus M2. M1 plus M2, here is it. Angle at the center, it is twice the angle at the circumference. It is clear, guys. Is this clear? When are you going to cover the linear algebra calculus? Do you have a schedule? Oh, I don't have a fit schedule. Thank you, thank you, and thanks for your consistency. Baba, I'm going to cover it. Don't worry, I'm going to cover it. I'm thinking of dividing these sessions into 2. Baba, just that I wanted to see how this midnight thing it's working, but I can see how you guys are supporting me. I will go live if you're supporting me, guys. I will continuously go live, eh? Yes, can I have a 50k? Yes, I can see what it works, guys. Yes, they will end up well. They will end up understanding. Abo? Yes, thank you for your contribution, Mr. Government. Abo? So guys, if you continue supporting me, I will support you too. So can you bring the channel to the 50K so that we can prove another theorem? Theorem 3, does it need to be proven? I don't think we have to prove that one, because theorem 3 is going to be this one. This is the line from the center. This is 180. 180 divided by 2 is going to be 90. The angle at the semicircle. This is 180 divided by 2 is 90. You are done proving. I've proved 2 theorems within a space of 2 minutes. Clap hands, man. Theorem 4. So we are moving. Can I please get a 50K so that we can move to no center included? Yes. It's not about mathematics, is not for everyone. It depends on the deliverance of the person who delivers it. Babo, if you deliver it very well, at least you are minimizing the number, that large number of people from. Yes. Thank you, Mr. Governor. Thank you for the wise words, guy. God bless you for that. If you bring positivity, we reflect back. Yes. Baba, with positivity, we reflect back. And God bless you, my friend. We will promote positivity in this group. Baba. Thank you very much, guys. Thank you very much. On 50K, we are doing theorem 4. Let me go in P. When I call P, wana skolo, kopa mo. Wana skolo, kopa. Malome. Alala, sengbuile. Hey, alala, sengbuile. Hey, alala, sengbuile. So yeah, guys. Let's deal with this theorem. We are talking about the theorems that we need to prove. Ne? We are proving theorems that they are frequently asked in the exam. Ne? So, should I prove? Let me hear from you guys. Should I prove theorem 4? Or I don't know. It's 4 or 5 somewhere here. Should I prove theorem 4 or should I go to the questions? Should we play question and answer question? Should I go and fetch a question and we answer it? Or should I prove more theorems? Questions, ne? Alright. Okay. Question it is, guys. Questions. I'm coming back. And thanks for just go and continue. Yes. Yeah. But I won't hit so hard today, ne? Let's play questions. Let's play questions. Let's play questions. Yes. Yeah, ne? Mm-hmm. Mm-hmm. This doesn't look like a metal cycle, eh? Let me put it here. Yeah. Well, okay. Guys, in the meantime, I have a website there. I charge 200 per month for this content. And please, guys, support. If you know or you really need my help, support my content. I only charge 200 per month. Ne? If you don't support, I don't know. Go and buy McFeast. Go and buy McFeast. But the McFeast, the disadvantage of buying a McFeast, tomorrow, you don't know where it went. You just go to the toilet, your 200 all dusted to the toilet. You should leave buying McFeast and convert that 200 into your advantage of learning. No. This line is not well drawn. List here and here and here and here. And this is our center, and yeah, and yeah, and O 1 and 2, and 1, and this is going to be 2, and it's going to be 64 degrees, and it's going to be the M for the food we are about to receive. For the food we are about to receive. And yeah. Yeah. And yeah. And for the food we're about to receive 8.1.1. Yeah. Hey. Yeah. Let's work, guys. Let's work. They're saying calculate for the value of P. The value of P. Man. We don't do that for the co-hosting. We are not for the co-hosting here in this life. We are helping. We are not for the co-host. So guys, what do you think? How can we find the value of P here? Who can tell me? This question is quite easy. All right. 180 minus 46. So guys, this theorem, like, how can we identify something it is a cyclic quad? Let's talk about the cyclic quad. Is SNPR a cyclic quad? Listen to the question. Let's talk a bit about the cyclic quad, ne? So that we educate each other. Why is it a cyclic quad? Is SRPN a cyclic quad? Is for the question. Yeah? The uncle is asking, is SRPN? Yes. Actually, how many cyclic quad do we have in this diagram? We are breaking down this question. You don't have to be lazy. We have two, ne? We have two, ne? So as we are having the two cyclic quad, it means that SNPR is going to be the cyclic quad. And what do we know about the opposite sides of the cyclic quad? So now, what is the opposite side of S? I want to ask this question before we can answer. The P1 is very easy. I want us to discuss this. What is the opposite side of S here? It's P, right? It's P. Thank you. So, guys, when you are dealing with, if you want to see whether something is a cyclic quad, that's why I'm advising learners, or guys, invest in buying highlighters, invest in buying colored pencils, ne? Invest in buying highlighters and invest in buying colored pencils, because by saying this all in black and white, it will do it. Whoa, how? What is how? How for what? Ask your question. Ask your question. Oh, so guys, this, you skip one angle, this is going to be the what? This, you skip one angle, this is gonna be the opposite side of S. Relative to what? SNPR. This side and that side, they are going to be opposite to each other. So, write for me the second cyclic quad. What is the second cyclic quad? Can I have the second cyclic quad here? Thank you very much for the gift. God bless for you. Thank you. Thank you. We have three. Okay, thank you. So, another cyclic quad. RMNP. It's a cyclic quad, guys. It's a cyclic quad. RMNP. It's a cyclic quad. So, if I want to determine for the value of P, obviously, what do we know about the opposite sides of the cyclic quad? What do we know about the opposite side of the cyclic quad? What do we know about the opposite side of the cyclic quad? Guys, let's write it in the right order. I know, hurry, you guys. They're equal. They are supplementary, guys. Ne? They are supplementary. Ne? They are supplementary. It means they add up to 180. Right? So when they add up to 180, it means for the value of the P, it means what are we going to do? We are going to take M and add it to P, and we are going to have 180 degrees. You don't just jump and say 180 minus 64. You'll get for the wrong, and you're gonna blame who? So guys, when we look for the value of P, we are going to say 64 degrees plus P degrees is equals to 180 degrees. Then the reason, what is the reason? The opposite sides of the cyclic quad, ne? Reasoning is very important. Ne? Reasoning is what? Opposite side of cyclic quad. Opposite sides of a cyclic quad are what? Are equal. The opposite sides of a cyclic quad, they are equal. No, angles. Sorry, angles. Yes, some people they fall onto that trap. They fell into that trap. When I said opposite sides of a cyclic quad, they wanted to say opposite sides of a cyclic quad, they are supplementary. Ne? Yes, they are opposite angles. They are supplementary. Thank you. Ne? Thank you. Let me bring this closer. Thank you. Then how do we get the value of P here? Take this one to the other side. Then we are going to have P being 180 degrees minus 64 degrees. Then this is going to be what? What is the value of this that we are going to be finding here? What is the value of this? 160. 116 degrees. Guys, Wawon, you stopped liking now. You stopped liking. And let's do the 8.8.2, 8.1.2, and what is it that we can find also? I need the value of O1. Hey. Manje seyashisa manje. Seyashisa manje. I need the value of O1. I need the value of O1. I don't want M1. I need the value of O1. O1. How can we find O1? Hey, M2 is going to be twice the angle of O2. Comments. Who commented? When is your next live? Oh, possibly tomorrow. Ne? Tomorrow. Yes, I need. Obviously, thank you very much for participating. Ne? So now, if I want to find my O1, so I believe people they are right here. Ne? They are okay now here. So what do we have? So we are going to have this and that, guys. This O2 and this, they are making theorem 2, guys. How do you see theorem 2? How did you notice this is theorem 2? Like on this gibberish, how do you notice this is theorem 2? Who can tell me the reason? Like, let's help each other. Let's enlighten each other in this life. Please like the life, guys. Please like the life. Natama likes much. You're not paying for this lesson, guys. Please like the life. How do you see this is theorem 2? I see people commenting for the theorem 2. But I want to know, how did you see this is theorem 2? People they are failing to answer me. Why people they are failing to answer me now? Okay, user. people. Guys, I need the reason. Pella, wait, why people, you can't, I can't, like, why am I asking the question? You are telling me O2 subtended multiplied by circumference. I don't want that one. Listen to my question. How did you see that, oh, this M2 is, this O2 is twice M2? How did you confirm that? What makes you to come to that conclusion? Angle at the center, double angle at the circumference, chord SN, M by MRN, then O2 is the exterior angle to a triangle OR. What are you saying? Yeah? Okay, guys, same arc, ne? Same arc. Thank you to those who responded with the same arc. Ish, just that the comments were I couldn't see your name, but thank you. You're on the right track. R is on the same arc as N. Wabon? They subtended the, like, what is the meaning of subtending? Maybe is this English, ne? What is the meaning of subtending? What is the meaning of subtending? Tonzintshe bengekho. Areni MRO makes the shape is. Thank you, Mr. User. Building, yeah, it's building, it's producing building, but hey, the crying emoji, my friend, ne? The crying emoji, my friend, eh? It will make us to the blog, eh? It will lead us to the blog, to the live, eh? The moment. It possessed me. That's why I rather be mathematically possessed by being dumbly possessed. On first time. So this and that, they're on the same arc. Right? They're on the same arc. So these two, like, you just take it from here, angle at the center, and from here the angle at the circumference. Just look at my fingers, guys. Look at my fingers. Angle at the center. This is the same arc, ne? This R is connected to this N with the same arc, and this same point, they are producing the angle at the center, and also the very same point, they are producing the angle at the circumference, guys. Highlighters, ne? The likes and thank you. You're supporting, eh? You're supporting. So is that understandable? Is that clear, guys? Is that understandable? This R and N, same center, and that circumference. Ne? Circumference, center, circumference. Ne? Vu. Same arc, coming back to the same arc, center, circumference. Now you know. Yeah, kite like, ne? The kite like, evolving from the same segment, ne? Next time you won't fail these things. I don't want people to be failing these things. So now we have a right. Now we can have this O2 is gonna be equals to 2M2. So we can confidently say O2 is gonna be equals to 2M2. This, what is the reason for this? The angle at the center is 2 times the angle at circum. Can you please check this reason whether it's acceptable or not from the exam guideline, ne? Please check for me this reason whether it is acceptable or not from the exam guideline. So this, how much is going to be my M2? My M2 is going to be 64 degrees times 2. Then how much is going to be my O2? How much is it going to be my O2? Okay, thank you very much. Ne? It means what is going to be acceptable. So how much is it going to be my O2? 128 degrees. 128 degrees. Thank you very much. It's gonna be 128 degrees. So now I was looking for O1. How can we get the O1, guys? How can we get the O1? How can we get the O1? How can we get the O1? Yes, the angle at the center, the angle at the straight line, they are supplementary also. Ne? The angle at the straight line, the angle on the straight line, yes? Then you are going to say, we got our O2 being 128 degrees. And what do we need also? We are needing, we need to be saying O1 plus O2. O1 and O2, they are also supplementary. We're going to say O1 plus 128 degrees is going to be equals to 180. Reason supplementary, supplementary angles on a straight line, right? Supplementary angles on straight line. Then what is going to be our O1? 180 degrees minus 128. What is going to be my O1? Angle. What is going to be my O1? 56. 52 or 56? Or 52. I believe it's going to be 52 degrees. And what is going to be my M1? My M1, how can we get M1? Yes. Angles at the semicircle. So now, what is SN? What do we call SN? What do we call SN? Thank you very much for your participation. It's not like I don't see your answers. I do see them, ne? And so far, so good, ne? So far, so good. I see them. The SN is going to be for the diameter, right? So since it's for the diameter, SN is going to be what? We can get M1 in two ways, We can get M1 in two ways. So Sn, since it's a diameter, the diameter subtends the angle of how many degrees? Does it subtend the angle of how many degrees? The Sn is subtends the angle of how many degrees? Yes, it subtends the angle of 90 degrees, right? That's an angle at the semicircle. Thank you very much for your participation. So it means M1 plus M2 is going to be equals to 90 for the degrees. Ne? So I'm wiping here. I'm wiping here. Hey, you can also use the second theorem. Yes, yes, yes. you're going to say M1 plus M2 is going to be equals to 90 degrees. Angle. So now, what is our M2? 64 degrees is going to be equals to 90 degrees. M1. So plus, so it's going to be what? Our M1 is going to be what in this case? Our M1 is going to be what? M4. Gee, what? What are you saying? The answer is going to be 24 or 26. 26, right? It's going to be 26 degrees. So this is the angle at the semicircle, ne? Angle at the semicircle. Yes, we can also use the second theorem, ne? So now we are going back to the concept of the arc. Which two points are on the same arc in order for us to use the second theorem? Which 2 points are on the same segment? Which 2 points are on the same arc? Huh? Is it M and R? Is it M and R? Is it M and R? S and R, right? So since it's going to be the S and R, apply the same formula like I did before, ne? This S and R, they formed the angle at the center. S and R, they formed the angle at the circumference. Is that visible, Mar? This, okay, let me do this. Angle S and R, same segment, the angle at the center. S and R, the same segment, the angle at the circumference. S and R, same segment, the angle at the center. S and R, the same segment, the angle at the circumference. Is that clear, guys? Is that clear? How am I doing it? Is that clear? Do you see it? I'm glad, my friends. I'm glad. Continue nailing it, eh? So we got our M1 being 26 degrees, eh? So now our M1, our O1 is going to be equals to what? Our O1 is going to be equals to what? I enjoy this lesson. I don't know why. So quiet and peaceful. Yes, it's going to be 20. No. I need to define the second theorem. We are defining the second theorem. Okay, thank you very much. Keep them coming. Keep the answers coming, guys. Ne? And like the screen, guys. Come on, guys. I need 100k likes, guys. I need 100k likes. And this one is the easy part of the question. I want to come up with the complicated question, like the usual me. I don't like to deal with this. This one, I'm just helping those ones who are failing to understand what is what, ne? These ones, I'm just helping those ones who are failing to understand how the theorems are working. I don't know. O2 is wrong. How do we do O2? Let's define O1 in terms of M1 day. Let's define O1 in terms of O1. Guys, wait, okay, it's fine. Let's fix the issue of M2. Let's fix the issue of M2. What is 90 minus 64, Kant? What is 90 minus 64? What is 90 minus 64? Wait. It's going to be 26, right? So what is the value of O1 here? What is the value of O1? What is the value of O1? O1 is 52. So if we say, hey, I see the error. Kanto, what's going on with this question, Vel? What's going on with this question? $90 minus 64. So 26 times 2 is going to be what? What is 26 times 2? 26 plus 6 plus 6 is 12. 4 plus 4 is going to be 52. Here is going to be 52. Here is going to be 52, but here we are getting 26. Aye. Yeah, you are right. I think it's a question error. I think this question is an error, right? Thank you very much. Thank you very much. It's fine. It's fine. Because both of them, they should fix. They should give us. They should correspond. Even if we are doing it with the second one, they should correspond, right? M1 is correct. Yeah, this one. M1. No, M1. Yes, this guy is supposed to be the diameter. Or maybe. No. It's either this one is not a diameter or whatever, but let me change the question. It's question error, guys. It's question error. Let's look at another question. This one is question error, but do you understand? But do you understand our approach? Like, so far so good. So far so good. It means this one is a chord. It's not a diameter, ne? Yes, it means actually we can change the center thing. Yes, thank you, goldfish. We can change the center thing. It means this, we can't use the theorem 3, ne? We can't use theorem 3 here, ne? It means this line, it doesn't pass through the center. But the tricky part is that this line OS, it has to pass through the center to apply the what? To apply theorem 2. It has to pass through the center, guys. It has to pass through the center in order for theorem 2 to be applicable. Or otherwise, it means this line is not a straight line. Otherwise, unless this line is not a straight line, or maybe we have to do this and shift this point of N to be somewhere here. This and this point of N, it has to be like this. Maybe it has to be like this. And now this line is no longer a diameter. Everything is correct. Angle P and angle P is 116. How is it 116? 64 plus what? Angles in the same segment. Alright, guys, let's not complicate, because the goal, ne, guys, Yes. Let me just clarify this, ne? Let me just clarify this. The goal for here is just to the goal in this life is just to understand how theorem works. Doesn't matter whether the question is correct or not. The goal is just how you approach the theorems. The theorems, they work absolutely the way we have approached this lesson. There's nothing wrong. Ne? Don't be afraid to get wrong answers, or don't be afraid to do whatever. Ne? Yes, this is going to be 116. Okay, it's fine. 116 degrees. Then how is angle P gonna help us? Or maybe this is only going to help us. Can we get angle S? How can we get angle S in this case? And let's just close this question by getting angle S. Because this one, I believe what is going to be what? Which comment? No, angle P is 64. Angle P. How is angle P 64, guys? No, 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 no. Angle P is 1. Why angle P is 116? This 64 is 64 plus. No, you guys, Mkari, are misleading me. Where's my calculator? Guys, 180 minus 64 is 116. Yes, P, it has to be 116. 64 plus 116, it has to be 180. 180. Why is it 180? Supplementary angles. Opposite angles of a cyclic quad are equal. So this is supposed to be like this. Is it okay? You see, 180 minus 64, it has to be 116. So P is going to be 116. Are we clear on that one? Are we clear on that one? Because I feel like here we are confusing each other. Is it thumbs up for P? Is it thumbs up for P? The angle 64 is the same arc as what? Thank you very much. So now, how can we get Q1? How can we get O1? The O1, basically, let alone, let's avoid theorem 3. Let's avoid the angle at the same segment. This is not the diameter anymore. Because of, we can see, if we are using the concept of the diameter, it doesn't correspond with the theorem 2. Here doesn't correspond with theorem 2. Basically, I will just shift this. Let me redraw the structure. Let me just make this structure like this for the sake of argument. Ne? Yes. Now it makes sense. Because, hey, we will have a trouble. Ghana, what is this point? Ghana, I forget very easily. Ghana, what did I put here? Yes, I put it N. Thank you. For the sake of argument, this is no longer a diameter because that angle, it doesn't correspond with our theorem. Now it's going to make everything to be complicated now. Because now this, it will no longer be a cyclic quad now, this thing. It will no longer be a cyclic quad. So we are only going to have one cyclic quad. Ne? And how can we get O1? Now I'm interested. Now it's getting very interesting now. Whenever I do this, it's getting very interesting. It's getting very sad. The question was asking for P. That's why they said P. Oh, no, we were long done with P. What I was asking for is O1. We were long done with P, ne? And now, yes, the P remains 116. And now, as I changed the structure now, as I changed the structure, I want the O1. How can we get O1? How can we get O1? Yeah, it's getting very interesting now. I need O1 now. No, let's leave the diameter one. We are done. No. We just most like, how can this be a diameter which it doesn't correspond with whatever that we were looking for? Because when we get, yes, because when we get this one, how can we get O1? Is going to be O2, O1, and O3, which means we are going to have this angle being O3. How can we get O3? Using theorem 2, right? Guys, let's just get O3 and let's get O1. Then let's leave this question. We can't dwell on this question for so long. Yes. How can we get O3? How can we get O3? Let's get O3, guys. O3. O3. I believe it's gonna be simple for O3. Yes, 360 minus 128 is going to be equals to O1 plus O3. Ne? No, we can. If you gonna divide this one, this. If you're going to multiply this by 2, you're going to get O1 plus O3. Anger. Guys, let me recheck this question. I feel like there's a lot that is going on here. Let me recheck this question. Let me recheck this question. Because now everything is getting complicated. And this one, I. It's the same thing. I'm restarting it, guys. I'm restarting it. Ne? Sn is the diameter. Yes, even on the question, guys. On the question, Sn is gonna be the diameter, guys. Ne? Sn, it becomes the diameter. Ne? And I'm having the angle there, up there, being the chord. The angle at the semicircle. And now I'm having a line which is drawn like this to the chord, right? And I'm having a line like this. And again, I'm having a line again like this which is drawn to the center. And I'm having another two lines like this and like that. This is the diagram. This is how the diagram looks like. Then I'm having R1 and 2, ne? And I'm having my S here, and I'm having my N, and I'm having my M1 and 2, and I'm having my P, guys. And this one, he is 64 degrees. And you guys, when we are calculating for this P, we said M. How did you calculate for P? Let's help those who just joined. It is like this, so we agree. Yes, the O, yes, thank you very much. O1 and O2. Yes, so the M2 plus P is going to be equals to 180. Reason, supplementary angles. What do you say? Opposite angles of quad, ne? Of a quad are supplementary. Opposite angles of a cyclic quad are quad are supplementary. So this is going to be what? M2 is going to be 64 degrees plus P is going to be equals to 180 degrees. Take this one to the other side. I'm going to have P being what? 116. Are we clear on P? On P, are we clear, guys? Can I get a thumbs up if we are clear on P? Are we clear on P? Thank you very much. Thank you very much. So I'm going to put my P here. This one is going to be 116 degrees. And now what I was looking for is M1. Ne? So I can see my P is the angle, my M2 is the angle at the circumference. So how can I get the M1? How can I get the M1? In order for me to get the M1, I will say what? Okay, let me just wipe here. I will say what? I will say M2 O1 is going to be equals to, okay, let's just use the 90 degrees. Since SN is the diameter, can we use that one? The semicircle. Okay, so we are going to say M1 plus M2 is going to be equals to 90. Angle at the semicircle. So our M2 is going to be 64 degrees plus M1 is going to be equals to 90 degrees. So what is going to be my M1? What is going to be my M1? (26 degrees). Ne? My M1 is going to be 26 degrees. So now, how can we get O2? My interest is on O2, guys. My interest is on O2. Because what made me to change this diagram, ne? How can we get O2? How can we get O2? How can we get O2? Yes. When we say 64 multiplied by 2, where's the wiping what? Where is that wiping what? Okay. So I'm going to have what? 64 times 2. 64 times 2. I'm going to have my O1 being equals to 2m2. And my reason is going to be what? The angle at the center. At the center is 2 times angle at circum. Yes. So my M2 is going to be 2 times 64. My O1 is going to be what? What is 2 times 64? What is 2 times 64? What is 2 times 64? Yes, it's going to be 128 degrees. So my O1 is going to be 128 degrees. So for the 128 degrees, for 128 degrees, from this 128 degrees, how can we get O2? How can we get O2? Yes. So now the O2 is going to be what? O1 plus O2 is going to be equals to 180. Guys, normalize writing these statements for the reasoning, because you can't just say 180 minus 128 is going to be equals to the answer. Then you expect, then you will say, maybe you are going to say, like, normalize, guys. Maybe when you are there, you are just saying 180 degrees is going to be, no, you're going to say O2 is going to be 180 degrees minus 128. Then on your reasoning, you are going to say, tell us, sorry, angles at the straight line are supplementary. This is wrong, guys. I'm telling you now, this is wrong. This is wrong. This is wrong. This is not addition, it's subtraction. This is wrong. You can't just subtract 180 and 128 and you are coming back and tell me, Hori, angles in a straight line are supplementary. When we talk about supplementary angles, we mean, Hori, angles at the straight line, they add up to 120. 180, I mean. So the correct way of drawing this thing, thank you very much, Koketsu. Thank you very much. God bless you. And yeah, God bless you with good marks. Like, the only way of making this to be right, you are going to write this thing exactly as it is. O1 plus O2 angle O1 plus O2 equals to 180. You are showing me, or when you add O1 and O2, these are angle at the straight line being added. The reason has to make sense, guys. The reason has to make sense. You don't just jump right away to calculate. That's why you get unnecessary incorrect answers, unnecessary wrongs. That's why you are getting them unnecessarily, because of you don't know how to reason. Your reasoning doesn't correspond with your calculations. That's why you're getting incorrect answers. Am I clear? Am I clear on that one? Here we are clarifying things like that. Your reasoning has to correspond. Now you can do your math, your fancy maths, whatever. You can do your fancy whatever, and you can substitute. And even your substitution, it has to be correct. This 128.01 plus 128 degrees is going to be equals to 180 degrees and jump over. Even when you are done substituting here, you can jump straight to the answer and say, oh, 1 is going to be equals to what? You can jump straight to the answer. The substitution is correct. And you can say 180 minus 128. 128 is going to be 52 degrees. Thank you very much. It's going to be 52 degrees. Ne? Is this? Oh, O2. Sorry, O2. Yes, O2. O2. Ne? Yes, O2, O2, O2. Thank you very much. Are we clear, guys? Are we clear? And even on the first one of a cyclic quad, guys, you don't just jump and say, hore, hey. You can't just jump and say, hore, 180 degrees minus 64 degrees is going to be equals to, this is equals to P. Then you are coming back and tell us, hore, okay, there's opposite sides, opposite angles of cyclic quad add up to 180 degrees. This is wrong, guys. This is very wrong. Ne? This is very wrong. Your reasoning, it doesn't correspond with what you are saying here. Your reasoning, it doesn't correspond with what you've written here. Guys. Ne? Write it. Define what you are telling us. Ne? Define what you are telling us. Your reason, it has to correspond with what you are telling us on the calculations. Here you are saying add up. Do we see addition here? Do we see addition here? Yes, no? Do we see addition here? But on the reason you are saying add up. But here do you see addition? I'm asking. Thank you, say Winterson. Thank you. There's no addition here. There's no addition. So why are you telling me or you are adding while you are not adding? That's why you get incorrect answers unnecessarily, guys. Ne? Shem, I'm giving proper coaching. I'm even rating myself. So you have to write it. Write that definition by math in mathematical manner. M2 plus P is going to be equals to 180. Opposite angles of cyclic quad add up to 180. Add up. Here's the addition side. Now it makes sense to me. Is that clear? I believe we are clear on that part. Ne? I believe we are clear on that part. So now, what is the value here? Obviously, we got 52, right? Here, we got 52. 52 degrees, right? Yes, meaning they are supplementary. Show that addition. Show that addition. Show us, hore, these two, when you add them, they are supplementary, guys. Show them. Show. Lanswara, mar. Lanswara, mar. I hope Lansalwara. So, I believe. Thank you. I believe we move from this question. I believe we move. Ne? I believe we move here. Because otherwise we will have a confusion that it's unnecessary. And it's clear now. If we are having 26 times 2 is 52, guys. Ne? Can the what? Where do you get these answers, man? Because now it makes sense. If I multiply this 26 multiplied by 2 is giving me 52. It makes sense now. Do you see it? Same arc, ne? Or it was the devil of the midnight who was confusing us. Man. Ne? It makes sense now, ne? I think it makes sense now. Because maybe these are the answers that I was taking on the comment sections. These are the answers that I was taking on the comment section. Ne? Aye, it's fine. So let's move to another question. Let's move to another question. Let's move to another question. Thank you. Thank you. Hey. Hey, 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 hey. I am sorry with this question. I'm sorry with this one. Eh? For those who I jump straight to. Hey, crying emojis. You will be reprimanded with those crying emojis. With this question, guys, you'll forgive me. Ne? It's I feel like it's interesting. Ne? Jumping straight. And for the S. And for the O. And for the line. And for the B. Yeah. And for the line. And for the line. And for the line, for the inspection, and for the line, yes, for the line, yeah, and for the G, yeah, for the G, and for the B, for the O, and for the T. And for the parallel, and for the line, and for the line, and for the F, and for the S, and for the O, and for the I think for the down, guys, eh? We are yes. I don't like, I always have to guys, yeah. Theorem 1, Theorem 2. Theorem 1 and Theorem 2. There's Theorem 1 here. From Theorem 1, Theorem 10, Theorem... Hey! Did you write all the letters? Oh, for the T. Yes, for the T. For the T. Yeah. Is it correct? Is it now correct? So we have to prove that... We have to prove, ne? We have to prove that... where's the little space? B, T, O, G is a cyclic quad, ne? So I'm going to explain the content, ne? One missing letter. Oh, it's for the P. It's for the P. It's for the P, guys. Thank you very much. It's for the P. It's for the P, that one. So, guys, for the cyclic quad, ne? For the cyclic quad, if I may to explain it very loud and clear. So for the cyclic quad, and please like, please guys, I need 100k. Please like. Get me to 80 before I explain the cyclic quad. I like you. You don't like? Come on. I'm going to continue at 75. But when I go Zwi, I have to see 80k. But in the meantime, it's fine. If you want to prove the cyclic quad, listen and listen closely. If you are proving the cyclic quad, ne? The cyclic quad, it's either you have to prove these two, when you add them, they are going to give you 180. Ne? You have to prove this is the scenario number 1. You are going to prove these two, when you add them, they are giving you 180, depending on the scenario that you are going to be having. You are going to prove that you are having the points subtending angles at the circumference from the same segment. So this has to be on the same segment. This one is what we call the butterfly. So if if A, B, they subtend C and D. If this one is the same segment or the same chord or the same arc, and they're subtending the angles are subtended by the same chord or the same arc at the circumference. It means C and D, they are equal. Ne? C and D are equal. They have to be equal. C is gonna be equals to D. If A and B, they are on the same segment. Ne? What about with D? I'm talking about I'm talking about the fourth. I'm talking about this theorem, guys. The cyclic quad. How does it work? Ne? How it works. I'm not yet on the question. Don't worry, we are coming here. But I'm talking about here. Ne? I'm talking about focus here. Leave the question alone. We'll come back to the question. Listen to me here. You have to prove, even though CD, if this is the diameter, this it has to be equals to that, and this it has to be equals to that, and this is going to be equals to that, and again this is going to be equals to that. Ne? Am I clear, guys? Am I clear with this information? Am I clear with this information? If this AB is the segment, which means they subtend CD, and CD is gonna be equal. If CD, they serve as the chord, ne? They subtend AB. Do you understand? If CA is a chord, they will subtend A. No, A or A. Wabon. These two, they are subtended by AC. Can I ask A1 and A2 and B1, B2, C1, C2, and D1 and D2? Ne? I'm going to ask a very simple question. And the question that I'm going to ask is going to be the repetitive of what I just said to you now. Ne? So what subtended B1 and D1? What subtended B angle B1 and D1? What chord subtended angle B1 and D1? Thank you. Thank you very much. This, it subtended D1 and D1 and B1. The same AC. So what subtended A1 and B2? What subtended A1 and B2? What subtended A1 and B2? If you are watching this. Thank you very much. It's going to be CD, guys. Ne? It's going to be CD. So what subtended A2 and C2. A2 and C2 angles are subtended by what? We are playing a little bit of a game here. Please like the video, guys. Please like the video. Thank you. Thank you. Thank you. Thank you very much. Thank you very much. And here's the next question. Up until you get used to it, you are going to get used to this one. After this live, you are going to know when they're asking you to prove the cyclic quadrilateral, which angles do you have to prove to be equal. So, first, what is the chord AB? Like the chord AB subtends which angles? The chord AB subtends which angles? The chord AB subtends which angles? People, they're still thinking about it. Thank you. There are only two people. Only two people. They got the right answer. C1 and D2. Thank you very much. I got you. I got a lot of people. I can see I got a lot of people. I got you. So what is the chord CA? Which angle that chord does chord CA subtends? Which angle that does chord CA subtends? We are going to understand this, guys. We are going to understand this quite and frankly. The chord CA subtends which angles? Thank you very much. Guys, get used to that, ne? Get used to this. Get used to it, guys. Get used to this. Get used to this. You are going to be alright. I'm telling you. Ne? So now we have to prove that BTOG is a cyclic quad. So let me just label this G1 and G2. And this one is going to be B1 and B2. And this one is going to be O1 and O2. And this one is going to be what? Oh, sorry. It's going to be T1 and T2. T1 and T2. Ne? Let me just put this like this. Please like the video. Like the video, guys. Like the video. Before we prove this, let's like the video. Like the video. Like the life. Like the life. Up until we get to 80K. Like the life. You are the one who requested for this live. Now I'm live. You don't want to like the live. Can't tell what's going on, guys. Why don't you like my live? Let's go. 80K, 80K. So firstly, we are going to teach each other how to approach questions like this. Ne? We are going to teach each other how to approach questions like this. So when they're asking for us to prove that BTOG is a cyclic quad, which angles do we need to prove that they are equal on the diagram? Tell me. Which angles do we need to prove that they are equal? Just two angles, which we need to prove that they are equal. Which angles do we need to prove that they are equal? BG and GO. Yeah, it's either. That's what you have to ask yourself. The first thing that you have to ask yourself. When they are saying prove that this is a cyclic quadrilateral, you have to prove that either you can get a chance, like you have to think about it, or is it possible for me to prove that O1 is going to be equals to T2, or B2 is going to be equals to G1, or B1 is going to be equals to T1, or B2 is going to be equals to G2, or B1 is going to be equals to T1, or you see how it goes. Yes, all angles within the butterfly plane. Thank you very much, my friend. Ne? Thank you very much. Thank you very much. Like the butterfly, guys, the butterfly. You have to know, okay, I have to, let me make a plan. Is it possible for me to prove that G1 is going to be equals to A2? Or what am I going to have? O1 is going to be equals to T2? Is it possible? How, if is it possible? Like, you have to think like that, guys. Think like that. Just go explore with your mind, guys. Yes, or a string tie. Yes. That's an example. Yeah, a bow tie. String tie. That tie, yeah. Angles in the same segment, right? Thank you. You have to prove those angles. So now, let's work on this question. I didn't see any meme. We are working together. So what can we do according to the information being given? What is it that we can do? What can we do here in order for us to prove this thing where it's a cyclic quadrilateral? Ne? And again, with the cyclic quadrilateral, lastly, guys, ne? Lastly, before we continue here, lastly, we have to prove that Askari here is gonna be the supplementary angles, if possible. And here we are proving what? The butterfly or the bow tie. And you have to prove again this exterior angle being equals to this angle A, B, C, D. Ne? I'm going to ask you this. Ne? What is D1 equivalent to? What is D1 equivalent to? What is D1 equivalent to? Thank you. What is A1 equivalent to? What is A1 equivalent to? What is A1 equivalent to? Thank you. This is the next thing that you need to prove, right? Ne? It's either you're proving the butterflies or whatever, or we have to prove what? We have to prove what? This guy, maybe this angle to be equal to that angle, but I don't think this time is gonna be possible for us to prove that. But let's see, or what can we use in our advantage in order for us to prove or this is the quadrilateral. So let's start, guys. Let's start. So what can we get from here? Ne? We have this one is E, ne? This is going to be E and G and whatever. So what can we get from this guy? What can we do here? We are having parallel lines. So can we use parallel lines in our advantage to prove the cyclic quad here? In the advantage. Okay. Yes, ne? Because if I'm watching this angle, S, it means, how are we going to prove it? This angle, S, is gonna be equivalent to what? This angle is gonna be equivalent to what? Okay, so we are going to have S being equivalent to T2, ne? S is going to be equivalent to T2. S angle S is gonna be equals to T angle T2. Ne? Then what is the reason here? What is the reason corresponding, right? Thank you. This is the reason corresponding angles. Angles, ne? And again, how are we going to use this insight into our advantage? What can we use? What else can we use? Hey, here we have to stretch our minds, eh? Okay. We have to stretch our minds, guys. Yes, GF is parallel to PS. GS is parallel to PS. So how are we going to do this question? So yes, we got this being equals to T2. So is T2 equivalent to something? Nah. S can also be. It can also be equals to, because they're co-interior angles. No, unless you are saying S plus this guy. Let me just say this one is T3. Ne? Are we going to need T3? Unless we prove that T3, unless we prove that T3, this T3 is going to be equals to G1 plus G2. G1 plus G2 has to be equals to T3. Also that it can help us to prove that this is a cyclic quadrilateral. Ne? There's no extra information. We have to fight with this question, guys. Yeah? We have to fight with this question. So let's see. Let's see. This is 90 degrees, ne? This is 90 degrees. Ne? Aye, man. We are done here, guys. Aye, man. We are done here. I think we are done here. Do you see what I'm seeing here? Do you see what I'm seeing? Turn chord. Yes, user, turn chord. I was thinking the same because this, it's a radius. So it means here it's a 90 degrees also. You see it? It's a 90 degrees. And here it's a 90 degrees. And yet S is going to be equals to T2. Then how did we do it? Okay. Wait. Don't worry. I'm figuring this out with you. We are not done. We are not done. Ne? We are not done. Don't get me wrong. We are not done. We are still figuring out. Ne? We are still figuring out with it. Don't worry. But what I'm seeing is the turn chord. Ne? And also, if I say, because I'm failing to understand, okay, well, how can this be like, okay, this T2 and this, how is it going to work for me, this first angle? How is it going to work for me, this one? Because I know if they are bisecting each other. No. This one is not 90 degrees. Sorry. It is extended, ne? This is not 90 degrees, guys. Hey, this is not 90 degrees, but this one is indeed 90 degrees, ne? This is not 90 degrees. But this one is 90 degrees. Turn chord theorem. There's a theorem, ne? If not the turn chord, the turn perpendicular to radius, man. Ne? Turn perpendicular to radius. Between the tangent and the radius, ne? Between the tangent and the radius, the angle that you are going to produce here is going to be 90 degrees. Thank you. Yes, not turn chord. Thank you. Thank you. Yes. Hey, sorry man. My mind is, yes, it's 90 degrees. Thank you. So here, what are we going to do with this information? Let's see. We have to prove now. So this GT is gonna, and TF, and parallel lines that we are failing to use. T2 is going to be x, but where from here? Where from here? Okay, sharp. Let me. This T3, because I can see the co-interior angles there. I can see the co-interior angle, so I can let T1 to be x, ne? But B1 is going to be 90 degrees, but how is it going to help me? But this one, T1 and T2, how can I prove that T1 and T2 plus G1 and G2, they're going to be equivalent to 180 degrees? It beats me. I chose the wrong question, but we have to finish it. It's fine. I will have to finish it, this one. So let's see. Let me check this question. Oh, sorry about that. Yes, GT is gonna be equals to TF. GT and TF, they're equal. Guys, listen, guys. This is the midpoint. Like this is not E, guys. The point of E is here, guys, ne? This is the point of E, sorry. This is the point of E, and this T is going to be the midpoint of ET. Basically, ET, let me indicate, ET is going to be equals to TF. This is the information that we were missing, ne? Now we can work, ne? I was checking the statement there, which ones? Yes. Now it makes sense. Do you see the light now? Do you see the light now? If ET is going to be equals to TF, is there light now? Let's do it. So it means it comes back to what I was suggesting. For this is going to be 90 degrees. It's going to be theorem 1, this one. Yeah? I was checking the statement now, like there's some information that I didn't include. Because the point E is not here, ne? And this guy is going to overlap to G. So this is not a point. We don't have any radius in this question. We don't have any radius on this question. So now we can work to prove that it's a quadrilateral. It's a cyclic quad. So if this it's a 90 degrees, BO. Oh yes, BO. Yeah, we only have one radius. DRCPT. There's no D. There's a D here. Man, there's no D here. Yes, E is on the diagram. E, it's a point. It means, sorry, TE and TF, they are going to be that. Ne? And now, what am I going to have? It means we are going to have TY. Let me just start here. Ne? Let me just start here and label this one. The problem in the question, they never labeled it. These T1s and T2s and T3 and T4. They are the questions that I came with. Ne? It's going to be 1, 2, 3, and 4. Ne? T1, T2, T3, and T4. So now, it means, what can we use in our advantage? You see where T4 is going to be equals to T1. Do you see that? Where T4 is going to be equals to T1. Do you agree? T4 is going to be equals to T1. Ne? And okay. 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 And we have this guy being equals to this guy. Ne? S is going to be equals to T1. And okay, this S is going to be equals to T4. Then this, we don't have another Z except this guy. Then we are going to have T2. Yes, T2 is 90. Thank you. T2 is 90. Thank you. Thank you. It means for T2, it's 90. Then we are done. Hi, we are done. We are done. We are done. T2 is going to be 90. T2 is going to be 90 and B1 is going to be 90. Hey, we fought, yeah? We fought. Hey, I didn't see your comment, Kangi. Pella, you comment once and you show tops. You comment once and you show tops. We won't see it. Or maybe I've been watching there, ne? Or maybe I've been watching on the side. But when I'm scrolling down, I don't see. Oh, I see the angle of the straight line. Yes, it means you're on the right track. So because of, like, if we have T3 and T4, it means T2 is 90 and T2 and B1, they are forming a butterfly. Ne? When they form a butterfly, remember our statements. Remember this and that. Ne? We are having something like this. And these two, they are 90 degrees. Yeah, same segment, guys. Ne? That's why I'm saying, Hore, whenever you're doing questions like this, you have to have a third eye, guys. Ne? You have to have a third eye. You have to see the answer before you're going to write. And how are you going to structure it? Obviously, you're going to say B1 is going to be equals to 90 degrees. Reason, tan, perpendicular to radius. Ne? That's the first thing that you are going to do. Then, what kind of a reason are you going to use for you to prove that if you are having two lines being equal between those reasons that I was teaching at the first in the beginning of the lesson? Ne? No, it's the line from the center to the perpendicular. Is the line from the center to the midpoint of the chord is perpendicular to the chord. Ne? Ne? The line from the center to the midpoint of the chord is perpendicular to the chord. In this case, because of, like, we didn't know, you were given two lines that are equal, and we saw Yeah, and is on, and is on, and is on. And if you have ET being equals to TF, it means what is the line from the center to the midpoint of the chord is perpendicular to the chord. This is your second statement. Ne? Your second statement, you're going to say maybe T2 is going to be equals to 90 degrees. Reason, line from center to the midpoint of the chord. Chord is perpendicular to the chord. In this case, in this case, the line from the center to the midpoint of the chord is going to be perpendicular to the chord. Can I get likes, guys? Can I get likes? Can I get 90K, guys? Because already, when I say the line from the center to the midpoint of the chord, this is the line from the center to the midpoint of the chord. You can't say the line from the center perpendicular to the chord. You are not sure this is perpendicular. You are not sure what this is perpendicular. But you are saying what the line from the center perpendicular to the chord. You are given this E, T and TF. Ne? You are given ET and TF to prove that whatever that you have to prove. But when you are coming, you are saying the line from the center perpendicular to the cause. While you are given the midpoint, you have to specify, guys. You respond to whatever that you see. The line from the center to the midpoint. Here's the midpoint of the chord. Is perpendicular to the chord. That's when you can put your perpendicular sign there. Right? Is perpendicular to the chord. And therefore, what are you saying? Then on your last statement, you are going to say, since B1, angle B1, and or you will say B1 ne, is gonna be equals to T2. What is the reason for this one? What is the reason for this one? What is going to be the reason for this one? Who can tell me? What is the reason for this one? Come on, guys. Road to 100K. Now we are not proven. Not proven. Not proven. Not same segment, guys. One. Little things, they will make you to get everything wrong, guys. Ne? Little things, guys. B1 is going to be angle T2. Both equals to 90 degrees. This is the reason. Finish. And they both equals to 90 degrees. And they. And they. English. Before angles subtended by the same chord, you are going to say B1 is going to be equals to T2. Both equals to 90 degrees. Ne? Is that clear? Because they are both equals to 90 degrees. So you are going to say both equals to 90 degrees. This is the reason that you are going to use. Anger. Am I clear, guys? Can I get a thumbs up? Or people are asleep? Ne? Yes. Then that's when you can confirm. That's when you confirm that B, G, O, T is a cyclic quad. You can just say cyclic quad or cyclic quadrilateral. Reason. Even here, you need a reason. Why are you saying BGOT is a cyclic quad? Reason, same segment. What segment? What segment? What segment are you talking about? G-O. G-O. Ne? G-O. You are done. This is how you get your 5 marks or 6 marks or 8 marks. If I don't go live maybe today, it means or I skip one day. It depends on whether I'm tired or not. But according to me, I go live every day. This is the format. Or maybe this format doesn't make sense to you. This doesn't make sense to you? Thank you, Said. Thank you very much, my friend. Does this make sense to you? Because sometimes, guys, you can see the answer like we did. You see how we've analyzed it before we write this. We analyze this thing before we write these reasons. Do you see them? Do you see what I'm talking about there? Do you see what I'm talking about? Or people are asleep? Balele abantu. Nilele. Ulalele. You shouldn't confuse the reason. Yes, you must learn a lot. Babo. Even the reasoning, guys, it has to make sense to you. Ne? The format, it's very important, guys. The reasoning, it has to make sense to the person you are writing to. Babo. You have to make sure that you put yourself in the person who's gonna make the question paper shoes. Or if I'm writing this, how is it going to be sword? I'm first time, hey, sword. This English is chowing me, Shem. Yes, Kai. Like you have to order it. You see, like the way you structured it. We found already. Okay, T2 is gonna be equals to B1 with our third eye. With our third eye. We indicated and write this, analyzed, and what. And we figured out that T2 is gonna be equals to D1. So now the problem is that how am I going to project this thing in paper so that a person can see my vision? Yeah, explaining now. B1 is going to be equals to 90. Reason, tan perpendicular to radius. T2 is going to be equals to 90. Reason, line from the center to the midpoint of the chord is perpendicular to the chord. You see it. B1 is now equals to B2. They are both equals to 90 degrees. BGOT is a cyclic quadrilateral. Reason, same segment, GO. Finish. You get your 6 marks or your 5 marks in your pockets. In your pockets, guys. In your pockets. Easy. Hey, but it's not easy, eh? You have to stretch your mind. You don't be lazy. These things, they are doable. You are just lazy. You are lazy to think. People, they are failing Euclidean geometry because of why? They are not allowing themselves to stretch their minds. Yeah, you have to practice every day. You have to practice. If you want something, you have to go for it wholeheartedly. If you see how Euclidean geometry defeats you, go for it wholeheartedly. Otherwise, you won't get it right. Trust me. Trust me. If you don't put your heart here and you think you're a genius or you think you are not clever. Pella, you see, I don't come here and just do this. I'm doing this with you. I'm getting confused with you. I'm putting myself in your shoes. I'm putting myself in your level. And when I'm putting myself in your level, I'm allowing you to analyze this thing with me, so that we can help each other. But if you don't put your heart in these things, me, I knew these things and I've done it a long time ago, but my mind is rusty now. Even the information that I'm trying to recall, but fortunately, I can recall a lot of information. That's why I can deliver the way I deliver. I recall a lot of information and I can see how the more I do this, the more I can reflect back. But there are some of the things that I've forgotten, but I'm remembering them as I'm teaching them. Ne? Yes, two eyes are not enough for sure. We have to come together and we do this thing. And as we are doing this, we are teaching ourselves. Ne? We are teaching ourselves in order for, yes, that we are teaching ourselves how to answer this individually. Unfortunately, let me count. What is the next question? What is the next question? Now the next question, they are saying, prove that G angle O what? B. They are saying that the next question, they are saying, prove that G angle OB is going to be equals to S. How can we prove this one? G angle OB is going to be equals to S. This one. Did you go over function already? No, I didn't cover them as yet, but we are coming. We are coming. Don't worry. Don't worry. We are coming. How can we prove that G angle OB is equals to S? Let's try and look at the diagram with our third eye, guys. With our third eye. How can we prove that? Let's see. And can I get 100K? We are closer, guys. 100K, please. 100K, 100K, 100K. Yes, let's bring our life to 100K, please. Please, man. Let's see. Let's see. Let's see. Let's see. Let's see. How can we prove this? G angle OB. The G angle OB, is it O1? Yes, no? I don't think it's necessary. Verse J. We already know. Or this is a cyclic quadrilateral. We're going to treat it as a cyclic quadrilateral the way it is like. Ne? Yes, angle at the same segment. So we see Hori O1. This G angle OB is O1, right? Yes, no? Is it O1, the G angle OB? But yeah, if you feel like, or if you are drawing a cycle here, it's gonna help you. Ne? If you feel like it's gonna help you, you can do it. Ne? But me, personally, I treat it as a cyclic quadrilateral. I know, hore, this is a chord, and this is a chord, and this is a chord. Ne? So let's treat it. So let's do O1. O1 is gonna be equals to what? Yes, let's start. O1 is gonna be equals to T1. Ne? Reason, same segment. Guys, don't be afraid. You don't have to explain a lot or proven on the previous. You've proved, Mus. You proved, Mus. How many times should I tell you this is a cyclic quadrilateral? You can even ask your teacher. You guys, you are afraid of your teachers. You are telling your teacher, "Oh, woman, I proved the most. This is a cyclic quadrilateral. Why can't you allow me to say, Hori, G B? It's a chord. Why can't you allow me to do that? Because of I already know this. It's a cyclic quadrilateral, so it has to be treated as a cyclic quadrilateral, right? Or maybe if you think like it's gonna give you a problem, ne? You can say on your statement of proving this, you can just say BGOD is a cyclic quadrilateral reason proven. Then you're just going to continue. O1 is going to be equals to T1, same segment. Then you're going to write your segment BG, right? Am I making sense to you? Am I making sense to you? Hmm? Am I making sense to you? So now, since we have our O1 is going to be equals to T1, which is same segment. Ne? Now, what are we having also? Now, what is the next statement? What is the next statement that we are going to write? The next statement? What are we having also? So we see here we have parallel lines, right? Yes, no? Do we have parallel lines, right? We have parallel lines, right? Yes. So we are going to do what? We are going to say T1 is going to be equals to S. Is this true? Reason is going to be corresponding angles, right? Corresponding angles, ne? Is going to be corresponding angles. Angles. Therefore, corresponding angles. Then you are going to say what? O1, which is our G angle OB. Here is it. G angle OB is going to be our O1. So we are going to say angle O1 is going to be equals to S. Reason, what is the reason for these two to be equal? What is the reason for these two to be equal? What is the reason for these two to be equal? What is the reason for these two to be equal? Thank you. Both equals to T1. That's the reason. There's no reason bigger than that. Babo? Both equals to T1. Both equals to T1. You've proved. You get your 3 or 4 marks. Babo? Chaile. Can I get 100K, guys? Can I get 100K? Can I get 100K? Only 200. What? Can I get 100K? As we are wrapping up. Thanks for joining my live, guys. Ne? Let me wait for this side and everything to be up here. Yeah. I think we have reached the end of this live. Ne? And thanks to those who are consistently attending my lives. Ne? I am thankful. I'm really thankful, guys. I'm really thankful for those who are consistently attending my lives. And yeah, I'm just hoping it's 4 o'clock, my brother. I've been live since 12. 4 hours. Joe. I'm giving you such big privilege. Yes. Tige lady, thank you. Thank you. Yeah. I'm trying my best, guys. Thank you, Rhea. Thank you. And I think we have reached the end of our live session now. But usually the question comes from question 4 of it means when you joined my live very late. Thank you, G babe. God bless you. God bless you. Thank you very much. Thank you very much, all of you guys who joined my live. Yes, it's not the first question. It's not. Yes, was J. Thank you very much, my brother. Thank you very much, Kausani. Yes, I know you joined my live very late. I've been live. I've been proving the theorems. I didn't even catch the what you call the the time to prove theorem 4. 12 o'clock, my brother. We are doing midnight session. Midnight is very quiet, nice, and simple, guys. And I wonder if you normalize studying from 12 up until 1:30 to 2, you will see how you study differently than you study in the afternoon, maybe around 3 or 4, or in the morning around. Ah, man. Me, I prefer these times. You see, these times, there's no disturbance, there are no crying cars, there's no what. That's when you. And guys, for the extra lessons, please, guys, if you need extra lessons and you know how you need them, please follow my website there. Our website, I mean. Whatever. Yes, no sirens. It's very quiet. Whatever. Follow our website. Is going to be blrtutoring.co.za. We go blue, guys. Yeah, this thing it's been working, Yes, I do. I do. Please go through my profile. If you go through my profile, you are going to see what I'm specializing with. I do physical sciences. It's 200 per month. You get the whole session but each subject. 200 maths, 200 physics. If you think all these things of the websites, they are going to you are not familiar with the website or whatever, can DM me on TikTok, but I prefer you go to website because whenever you enroll, it kicks you straight to my number on WhatsApp. That's my website, our website. Hey, why do I say my? No, I'm not alone in this thing. But the number that you are going to enroll on, the person that you are going to text, you're going to be talking to me personally. Ne? And those who just enrolled, I will attend your text while as I'm wrapping up this live. I'm going to attend now to your text. And yeah, thank you for your support. And I will make sure that I deliver. I deliver the content. And if you know that, or maybe you don't have that 200 of joining my classes, follow, guys, subscribe to my YouTube channel. This live it's recorded. I'm going to download it and I'm going to upload it on YouTube. So far I've uploaded too few videos, but the upload process, obviously when I download it takes a nyana time, but I'm sure in 2 to 3 days this live is going to be on YouTube, on my YouTube channel. And I appreciate your time, guys. I appreciate you taking yourself very seriously. Don't be lazy. Put your heart in passing. Like, try by all means. You can't do many things. You can't kill many stones in one bed. You can't groove and pass. Sacrifice groove. You'll groove in December. Pass first. Phetha lebaka le la o phasa. Then o tla ira dilo tsa gago after. Because why is physics ya hao or le maths ya hao, like you wish hore sometimes o nka e tseya wa isa go 60% or o kgone go applyela memmereko me sharp or o kgone go applyela di-varsity tse sharp for di-requirements tse sharp, mara wena like you don't stop playing around, guys. It's bad outside here. It's very bad. Memmereko e nyaka di-requirements, di-course di nyaka di-requirements, wa ntlhalohanya, and we are here to help, wabo. But yeah, it's up to you. It's all up to you, guys. But either way, thank you, Vas J. Thank you very much. Otherwise, I would like to thank you all who've been consistent and listen to teachers. Those teachers who are teaching you there, they are not just there for fun. Maybe some of them, yeah. We can't say all of them, they are not just there for fun. Because, yeah, hey, we're having teachers in many cases of whatever, but I'm not here to specify that. But hey, but please take your life very seriously. Do your own research, study, make sure that you invest on your education. And yeah, don't forget to like, share, and follow. Ne? Don't forget to like, share, and follow. And again, I'm saying this, if you need private lessons, 200 per month, you go to my website, blrtutoring.co.za, or maybe BLR Tutoring. You will see the what you call, yes, thank you very much, moderator. You'll see the very logo, the very same logo that we have put me and Mrs. TK there. The very same logo, it is there on Google. Re teng ko Google. Ho sa re tsebe re Google or Google re teng. Wa ntlhalohanya. Re ra dilo tsa mannete. This business is not for place, like we are not playing here. We are registered. It is a formal business. And the classes are continuing every Monday to Friday. Classes every day. You get full of my attention every day. We invest in these learners. We are not playing. Babo? Yes. And yeah. Thank you very much, guys. Yeah, let me dismiss. Hey, I'm tired. Yo. Yes.